All right, let's take a look at solving this three-variable, three-equation system. We want to find the solution set for the system, show our work clearly, and label the equations as indicated. If the system is dependent or consistent, we want to say so. So I look at these equations, and I make the choice to eliminate x first. I could have just as well chosen to eliminate y or z, but I chose to eliminate x, and the reason I've done that is because the coefficients are the smallest on x, and there are not any convenient situations for eliminating any one of the other variables. Alright, so I'm going to multiply 5 times equation A and add to that negative 3 times equation B. And notice that what I'm doing is taking the coefficient of x in B and multiplying that by equation A and vice versa. Taking the coefficient of x in equation A and multiplying that by B. Since x in the two equations has the same sign, one of my factors that I multiply by has got to be negative in order for these coefficients to be opposites. So I chose to make the 3 negative. I could have just as well made the 5 negative. So 5 times equation A gives me 15x plus 30y plus 45z equals 60. Negative 3 times equation B gives me negative 15x minus 30y minus 45z equal negative 60. So everything cancels out on the left, leaving me with 0. And 60 plus negative 60 is 0. So 0 equals 0 is a true equation. So all I know at this point is that the system might be dependent. Because I have not used all 3 of the equations, I cannot conclude that the system is dependent until I see what happens when I involve equation C. So I'm going to use C and A. I could have just as well used C and B. And I'm going to take the coefficient of x in equation C and multiply that by equation A, and take the coefficient of x in equation A and multiply that by C. So that will always work. Sometimes that's not my smallest factor to use, but I can always use the coefficient of the variable I'm eliminating in one equation times the other equation to get opposite, and vice versa to get opposite coefficients. So 3c is 24x plus 48y plus 72z equal 96. Negative 8a is negative 24x minus 48y minus 72z equal negative 96. Everything cancels on the left, leaving me with 0, and 96 plus negative 96 is 0. I get another true equation that has no variable in it. So the system is dependent. So on this type of problem, I actually want to state that. System is dependent and has infinitely many solutions. So I want to describe the solution set. So the solution set is the set of all ordered triples, x, y, z, such that, and I can take, because each of these equations is actually a multiple of any one of the others, all 3 of these equations represent the same plane. When that happens, I can represent the solution set using any one of the 3 equations. In this case, I've chosen to use the first equation. Now, not every dependent system has this format, but when I get 2 true equations, 0 equals 0, when I involve all three equations, this is the case.